Question number 22. Flight from A to B, track 350, true airspeed 310, wind velocity 240 at 30 knots. Distance is given, fuel on board, reserve and fuel consumption. We have to calculate time and distance to CP, PNR and still air range. So let's start with critical point. As we all know, we are going from A to B, a total distance of how much? 1500 nautical mile, a total distance of 1500 miles. Let's draw the table like we always do. A from to table, a true airspeed table, a track table, wind velocity and ground speed. Ground speed outbound from A to CP, ground speed outbound from CP to B, and ground speed homebound from CP to A. Okay, these are your three elements. So let's take this is your CP. So you are going from A to CP, CP to B, and CP back to A. Now the question says the true airspeed for all the cases is 310. So 310, 310, and 310. Now the track is 350. So when you are going from A to CP, your track is 350. The wind velocity for all cases will be same, 240 at 30 knots. So 240 at 30 knots. Okay, 240 at 30 knots. Now let's solve the row number 1, which is speed 310, track 350, wind velocity 240 at 30 knots. So let's solve that. So using your CH3 and scientific calculator, we will solve this sum. Okay, so true airspeed given to us is 310 knots. True course outbound is 350. Wind direction is 240. Wind speed is 30 knots. Okay, so this is what you can see. True airspeed 310 given to us. Force 350, speed 330, and direction is 240. So the ground speed that you get is 318.9, which is approximately 319 knots. 319 knots. So let's write the ground speed for row number 1 is 319. Now let's go to next question. Next part. When you fly from critical point towards point B, you're following a track of outbound which is 350. Same 350. So let's put track 350 and let's calculate ground speed now. So now ground speed will be the same. The task is same, track is same, winds are same, so ground speed will also be same 319. Now when you are coming back from critical point to A, so critical point back to A, when you are coming, your direction of flight will be reciprocal of outbound direction. So if outbound direction is 350, homebound direction will be reciprocal of 350, which is 170. So let's put that in CX3 now. So true airspeed is 310. True airspeed is 310. True course is 170. Wind speed is 30 knots and wind direction is 240 knots. So your ground speed in this case, dash 310, course 170, speed 30 knots, direction 240 knots. So ground speed 298.4. So 298 knots. 298 knots. So this is the full table. Okay. Now let's go to distance to critical point equals to dho plus h. So total distance d is 1500 miles. H is how much homebound speed is 298, and outbound ground speed from critical point to point B is 319. So do this 1500 plus correction into 298 is 447,000 divided by 298 plus 319 is 617. So critical point distance will be 447,000 divided by 617, which is equal to 724 nautical miles. 724 nautical miles. Simple. Now let's find time to critical point. Is distance to critical point divided by ground speed outbound from A towards critical point. So 724 divided by ground speed outbound from A to CP is 319. So 724 divided by 319 is 2.2 or 2 hours 16 minutes. 2 hours 16 minutes. So that is your time towards critical point. Okay. So this is the final answer, distance and time. Now let's go to next part of the question which they have asked us to find PNR, time and distance. So for PNR, the same table from to track, task, winds and ground speed. You're going from A to B. There is a PNR, point of no return. So always for PNR there will be two rows. Ground speed outbound from A to PNR and ground speed homebound from PNR to A. Ground speed outbound A to PNR will be how much? The track will be, now outbound track is what? 350. A to PNR outbound track is 350. True airspeed given in the question is 310. Wind velocity is 240 at 30 knots. So that wind is same for both route of flight. Task is also same. Now when you come back from PNR to A, your reciprocal direction you will be flying. So 170 will be your track. Now let's find the values in CX3. So initially track is 350 from A to PNR. Speed is 310. Speed is 30 knots and direction is 240. So ground speed is 298.5. Okay. So task 310. True course correction over here. 350. Yeah. So A to PNR, task 310, track 350, velocity 240 at 30 knots. So your speed will be 318.9. So approximately 319 knots. 319 knots. Now when you're coming back from PNR to A, only your direction of flight will change. Everything else will remain the same. So 170, 310 task, 30 knots, 240 direction. So your ground speed will be 298.45 or 298 knots. 298. So let's use the formula distance to PNR equals to endurance into outbound into homebound speed O plus H. Now what is endurance? Fuel on board minus reserve divided by fuel consumption. So fuel on board is what? 12,000 pounds. Fuel on board is 12,000 pounds divided by fuel consumption 1,800 and reserve is minus 2,000 minus 2,000. So 12,000 minus 2,000 divided by 1,800. So endurance will be equal to 10,000 divided by 1,800. So endurance will be 10,000 divided by 1,800, which is 5 hours 33 minutes. 5.5 or 5 hours 33 minutes. So let's put that here. 5 hours 33 minutes into 319 into 298 divided by 319 plus 298. So distance to PNR will be equal to 5 hours 33 minutes into 319 into 298 divided by, so 319 plus 3298 is 617. So distance to PNR will be 528,122 divided by 617, which is 886 nautical mile. So let me do 5.5 into 319. Okay, so correction. This value is 522,841. So 522,841 divided by 617 is 847 nautical miles. So the distance to PNR is 847 nautical miles. So numerator is 522,841, denominator is 617. Time to PNR will be distance to PNR divided by ground speed outbound from A to PNR. So that will be equal to 847 divided by 319. So that is equal to 2 hours, 2 hour 39 minutes. 2 hour 39 minutes. So this is how you do the sum for PNR. The table, formula and time. Very simple. Once you get the table, all you have to do is substitute the values correctly and do the calculation part. Next, last part of the question is calculate still air range, which is fuel on board divided by fuel consumption into TAS. So fuel on board is 12,000, fuel consumption is 1,800 into TAS, which is 310. So 12,000 into 310 is 372 divided by 1,800. So still air range is 2,066 nautical miles. Still air range is 2,066 nautical miles. Okay, so remember this. So with this, we have solved all the three parts of the question: CP, time to CP, distance to PNR, and time to PNR, and still air range. Okay. Next question, question number 23. Next question, question 23. You have got flight from A to B, distance 1,100, track 020, winds 220 at 30, consumption rate 1200 pound per hour, fuel on board 10,000, reserve 1500. And now you have got true airspeed N. Now true airspeed N means all engines operating. N stands for normal. All engines operating. So that means let's say there are your aircraft has two engines, and if both engines are working properly, there is no engine failure. We call it normal. So true airspeed under normal conditions is 210 knots. True airspeed R, Romeo. R stands for reduced. R stands for reduced. So that means when there is an engine failure, any one engine, your true airspeed will reduce. Your true airspeed will reduce. So that R stands for reduced true airspeed of 185 when there is an engine failure. Now let's go to calculate time and distance to critical point to PNR and still air range. So simple. So let's start with critical point. Now we have A to B, and then we have a critical point here. We have a critical point here. Now critical point is the point where you assume your engines have failed, and from that point you can either continue, you decide to continue to your destination or come back to point A. Either way, the time taken will be the same. The time to go from CP to B will be equal to time to go from CP to A. Okay, equal amount of time. So at critical point there is engine failure. So that means when we reach critical point, okay, once your aircraft reaches critical point and there is an engine failure, okay, now you will fly with a reduced true airspeed. So when you take off from point A, after taking off from point A, you will fly towards point B. During your journey, there will be an engine failure. Let's say it happens at critical point. Now at this point, you will make a decision to continue either to your destination or back to point A. Okay, so it will take same amount of time to go or come back. So when you go from A to CP, everything is working fine till your engine stop working at critical point. So when everything is working fine till you reach your critical point, you will be flying at a true airspeed N. True airspeed N, November, normal. Okay, because up from A to CP everything is fine, so you will be flying at a normal true airspeed. At CP, when your engines fail, you will be flying at a reduced true airspeed. So let's say if you decide to continue, if you decide to continue towards point B, you will be flying from the critical point. You will be flying at a reduced true airspeed. If you decide to continue to fly back to point A at your departure airport, you will be flying at a true airspeed of reduced value. True airspeed of reduced value. Okay. So A to CP normal speed. After CP, when your engines fail, you will be flying at a reduced task. If you decide to go towards B, or if you come back to A, again reduced task because you are flying only on one engine. So now let's draw the table to track your tasks, your winds, and your ground speed. Now ground speed outbound from A to critical point, ground speed outbound from critical point to B, ground speed homebound from CP, from critical point back to A. When you go from A to CP, the track that is given to you is 0 to 0. The task that is given to you is normal task 210 knots. 210. From A to CP 210. Everything is working good. Wind velocity 220 at 30. 220 at 30. So what will be your ground speed? So let's use your CX3 calculator. So over here at your CX3 calculator, you have true speed given, true force given, wind speed and wind direction. So we will substitute the values. So your true airspeed is normal 210 knots. True airspeed normal is 210 knots. Your course from A towards critical point is 0 to 0 20 knots. Speed is 30 knots. Direction is 220 knots. So what will be your ground speed? Your ground speed will be 237.94. 237.94. Correct? So we can take it to be 238 knots. 238 knots. Now let's go to row number 2. You're continuing from CP to Point Bravo after engine failure. So your track will be the same outbound track 0 to 0. Now true airspeed, very important point. True airspeed after engine failure will be reduced true airspeed. Okay, TASR. So now you will use the reduced value of 185. A reduced value of 185. So don't take 210, take 185. Speed is the same 220 at 30. Now ground speed. Let's calculate ground speed. So true airspeed is speed from CP to B is 185. Course is 0 to 0. Wind speed 30 knots. Wind direction 220. So your ground speed will be 212 decimal 9. So you can take it to be 213. 213 knots. Now the last row. You're coming back from CP to A after engine failure. So coming back, your direction of flight will be reciprocal. So reciprocal of 0 to 0 is 0 to 0 plus 180, 200. Okay, coming back, your direction is 200. Going ahead, your direction was 0 to 0. True airspeed, again, you're coming back at a reduced true airspeed, so speed of 185 knots. Wind velocity of 220 at 30. Your ground speed will be how much? Let's calculate that. So true airspeed is 185. Track is 200. 30 knots at 220. So this is the field information. 185 knots, 200, 30 knots wind speed, wind direction 220. So ground speed is 156.52. So take it to be 156 only. 156. So now your table is complete. Let's go to formula. dCP is equal to dHO plus H divided by O plus H. Now your total distance D is given in the question and it is equal to 1100 nautical miles. So 1100 into homebound speed is 156 ground speed divided by 156 plus outbound speed with engine failure 213. So multiply 1100 into 156. 171 600. 156 plus 213 369. So distance to critical point will be 171600 divided by 369. So that is equal to 465 nautical miles. 465 nautical miles. Now time to CP. Time to CP equals to distance to CP divided by ground speed outbound from A to CP. Outbound from A to CP, which is 238. So 465 divide 238. So time to CP is equal to 38. 1 hour 57 minutes. 1 hour 57 minutes. This is your distance to CP. This is your time to CP, 1 hour 57 minutes. So this is how you do. Now over here, the previous three sums that we have solved had only one task. Over here we have two types of tasks, one before engine failure, task normal, one after engine failure, task reduce. So that concept, now once you have understood that, you will use that task which is required. In case of before CP, use the normal task. Anything at and after CP, if there is engine failure, use the reduced task given to you. Now let's find PNR. Now PNR is similar. You're going from A to B. There is a point of no return somewhere in your flight route. Okay. And the point of no return is that place beyond which if you go, you will not be able to come back safely to your departure airport because of insufficiency of fuel. Okay, so once you cross point of no return, you have to continue to point B. But if you are at any point before point of no return, you can come back to your home airport safely. Okay, now point of no return is considered for anything other than engine failure conditions. Okay, any life events which can trigger you to make a decision to come back to your home airport. Let's say you have taken off and there is some medical emergency on your board. So after taking off, you will not reach a very far distance. You will be somewhere near your home airport. You will not have crossed your point of no return yet. So in that case, you can come back. Okay, if you have taken off after spending some time in cruise, you get to know that your destination airport has some problems, the runway is closed or the weather there is bad, and you want to divert or you want to come back to your departure airport. So if you are before point of no return, anywhere before point of no return, you can come back or divert anywhere else. So point of no return is relevant to such life events, okay, but not engine failure. But if the question states that you have to calculate point of no return for engine failure, we will calculate that also. We are going to do those sums also. Okay. So now let's draw the table same from and to, your track, your tasks, your winds, and your ground speed. So ground speed outbound from A to PNR and ground speed homebound from PNR to A. Now outbound track is 020, homebound track is 200. Okay, and now in case of PNR, like I say, there is no engine failure for PNR sums. If the question states that there is an engine failure, because sometimes even though PNR sums originally do not have engine failure considerations, we can also do PNR calculations considering an engine failure may happen before we reach PNR. Okay, so in that case, again, if there is engine failure for PNR sum, again you will use reduced task if you're coming back after PNR failure, engine failure. Okay, but now in this case, they have asked us to calculate just the simple distance and time to PNR. So there is no question of engine failure. So you will only use the task that is working for all engines. That means the true airspeed when all engines are working. The reduced task which was given to us in this case will not be relevant. So task is how much? 210 knots and 210 since no engine failure. Wind velocity is 220 at 30, 220 at 30. Let's use CX3. True airspeed is 210, true course is 20, speed is 30 wind speed, and wind direction is 220. So your ground speed will be 237 decimal niner knots or 238 knots. So ground speed will be 238 knots. Now the second row, we have a true airspeed of 210 because engines are working fine. True course 200, wind speed 30, wind direction 220. And now you get the resultant ground speed 181 decimal 5 knots or 181 knots. Our table is complete. Let's use the formula. Distance to PNR equals to endurance into outbound into homebound, homebound plus outbound. Okay. Now what is our endurance? Formula fuel on board minus reserve by fuel consumption. Fuel on board is 10,000 pounds. Reserve is 1,500. So 10,000 divided by minus 1,500 divided by fuel consumption, which is 1,200. Fuel consumption is 1,200. So endurance will be 10,000 minus 1,500 is 8,500 divided by 1,200. That is 7 hours 5 minutes. 7 hours 5 minutes. Okay. So 7 hours 5 minutes into 238 into 181 divided by 238 plus 181. So distance to PNR equals to 7 hour 5 minutes into 238 into 181. So that is equal to 305,135 divided by 238 plus 181, 419. 305,135 divided by 419 equals to 728. So distance to PNR equals to 728 nautical miles. Okay. Time to PNR will be equal to 728, that is distance divided by ground speed outbound 238. So 728 divided by 238 is equal to 3 hours 3 minutes. 3 hours 3 minutes. Okay. So 728 nautical mile is the distance, time is 3 hours 3 minutes. So this is how you calculate the distance to PNR and time to PNR sum. Now the last part, we have been asked to find still air range. Simple, fuel on board divided by fuel consumption into TAS. Now here the TAS that they are talking about is normal TAS because no mention of engine failure. So total fuel on board is 10,000. Consumption is 1,200. Normal TAS is 210. 210 into 100 divided by 12. So still air range is 1750 nautical miles. Okay. Still air range 1750 nautical miles. So with this sum, we will stop here. I hope you have understood these two sums very well. The first sum that we did was only consisting of one task. Now the second sum, two tasks, And when to use what kind of task, I have told you very clearly. Normal task, all engines operating. Reduced task, engine failure at critical point. And if the question mentions that at point of no return the engine has failed, then reduced task will also be applicable to point of no return formula. Okay, that data. And apart from that, solve these two questions again twice and the third time without seeing the solution on your own. Okay, so do all the sums we have done till now, practice them, very important. And once you know how to solve them, then your speed will increase and you can solve the same sum in less amount of time. So do come in the next lecture in which we will solve the next CPPNR sums. Do hit the like button if you have liked the video. Let me know that. Subscribe to this channel if you have not done it, and do share this video with all your friends. Let me know in the comment section your doubts, your questions, your feedback. Thank you for your time. Keep learning.